Hi everyone, today we will learn about future value annuities, or other words called ordinary simple annuities. So the goal is to calculate the amount of future value of a simple ordinary annuity. Let's start with some examples so we gather an understanding of what these types of questions look like. So Billy Bob Joe Johnson is saving for a new tractor by putting $300 in a savings account at the end of each month. So as we notice, there's a regular payment being made of $300. Little Jenny is depositing $850 at the end of each 3 months for all 4 years of high school while trying to save up for college. So again, a regular payment is being made. This is the big difference between compound interest and simple interest to future value annuities, or annuities in general, that there is a regular payment being made rather than simple and compound interest. There's a principal payment made at one time. So to define an annuity is a series of equal payments made at regular intervals. Specific to an ordinary annuity, payments are made at the end of each compounding period. So therefore, the amount of an annuity is the sum of the regular deposits plus interest. That is our definition. So just let's review compounding period. So the number of times per year. Annually is 1 time. Semi-annually is twice a year. Quarterly is 4. We have 12 months in a year. Weekly is 52. Bi-weekly is 26. And daily is 365. You could see that. So let's look at our first example. So suppose $450 is deposited at the end of each quarter for 1 year in an investment account that earns 10% per year compounded quarterly. Complete the following table. So what we're calculating is the interest per quarter and then our end balance for each quarter. So as we start our first quarter, we have $0. Therefore, there's 0 interest earned on $0. And at the end of that quarter, a regular payment of $450 is made. So therefore, at the end of the quarter, we have $450. Now we begin our second quarter with $450. Our interest earned in each quarter, so for this quarter, I'm going to write this here, 10% divided by 100 because we need our decimal, divided by 4 because that is our compounding period, quarterly. So to calculate our interest in each quarter, 10 divided by 100 divided by 4 is 0.025. 0.025. Therefore, in this first quarter, in our second quarter, interest earned would be $450 times 0.025 equals 450 times 0.25, $11.25. So the amount of interest earned at the end of that quarter, we deposit another $450 for a total end balance, $450 in the beginning, what we start with, plus $11.25 of interest earned, plus another $450 deposited at the end, for a total $450 plus $11.25 plus $450, $911.25. So at the end of the second quarter, we have $911.25. That is what we start with in our third quarter. We calculate our interest in that quarter, multiplying it by 0.025. 911.25 times 0.25 is $22.78. Again, at the end of that quarter, we make another payment of $450. So to calculate our end balance, $911.25 plus our interest earned, for a total of $911.25 plus $22.78 plus $450, $1,384.03. To calculate our last quarter, we start with $1,384.03. We calculate our interest in that quarter. So 1,384.303 times 0.025 is $34.60. We make another payment at the end of that quarter for an end balance to be 1,384.03 plus 3460 plus 450 is $1,868.63. Therefore, our annuity at the end of 1 year, investing $450 quarterly at 10%, is $1,868.63. So we have a formula for this rather than going through each quarter and calculating. We have future value annuity formula. FV equals R multiplied to 1 plus I to the power of N, subtract 1 all over I. So FV is our future value. Which is the sum of regular deposits plus interest. R is our regular payment. In dollars, obviously. I is our interest rate per compounding period. And we always want that in a decimal. And lastly, N is the number of compounding periods. Which is years times compounding periods. So let's look at some examples. So in example 2, we're specifically solving for n values. So finding n, find the number of payments in each investment. So $25 at the end of each year. So therefore, at the end of each year, that means we are compounding annually. So 12 years times 1 is 12 compounding periods. $25 at the end of each month for 6 years. So each month in a year, that means there's 12. So we are compounding 12 months. So 6 times 12 compounding periods is 72 total periods. $25 at the end of every 3 months for 2 years. So every 3 months is quarterly. So for 2 years, 4 times is 8 compounding periods. Finding I for each interest rate, what value would you substitute for I in the ordinary annuity formula? So 6% per annum compounded monthly. Annum is just as a year. So 6% per year compounded monthly. Sorry, annually. That means that is once. 6% divided by 100. We always want our decimal. Divided by once. We're only compounding it once. 6 divided by 100 divided by 1 is just 0.06. 12% per annum compounded semi-annually, so that means twice. So our 12% interest is divided by 2. 12 divided by 100 divided by 2, 0.06. With 5% per annum compounded quarterly. So that is 4. So 5% divided into 4. Five divided by 100 divided by 4 is 0.0125.